recording. And there we go. And now I'm going to go ahead and open up the whiteboard so everyone can see what I'm doing. Everybody see the whiteboard? All right, great. Thank you. All right, so what's an essential skill from chapter 2? Let's see if we can do this. All right, we have a name. I'm going to give you the name of two things. Three things. Ammonium sulfate, ammonium sulfite, and ammonium sulfide. Now, these compounds look very similar as far as the name goes, but we should be able to, or at least by next week, we should be able to look at this and go like, I've got this, I can do this. Okay, now, while I'm thinking about it, because many times if I don't say it while I'm thinking about it, I won't say it. Go to Google. When you're finished working with your problems in the textbook, go to Google and download what are called naming compound worksheets. Name and compound worksheets. You see, high school teachers in particular, they love to write worksheets. And I taught high school briefly, very briefly. I didn't last very long. And the one thing that I was told over and over again is you never ever let high school students have a moment where they're not working on something, because they will go crazy, and they do, and they did. And so you have to have worksheets. So these high school teachers, they put out worksheets, and there's tons of worksheets for everything. So go to Google and say, Google, naming compounds worksheets, and there are thousands of them, and they are good practice, and they come with answers. Make sure you get the ones with the answers. Okay, so what is its essential skill here? We have to be able to take this name and turn it into a compound. Now, I caution you, you cannot just write the compound down without going through one step, and that step is to write out the individual ions. So what's ammonium? If you look on page 66, you should start memorizing these. Ammonium is NH4 plus, and sulfate is an SO4 2 minus. Now the charges are not the same, the plus and 2 minus, because what's the charge of any ionic solid is that it has to be equal 0. So what do? We swap the charges and we end up with ammonium, which is a polyatomic ion, which means we have to put it in parentheses since there's two of them, and we have the sulfate. Okay, don't forget, if you have more than one polyatomic, and ammonium is a polyatomic, that you have to put it in parentheses. Okay, now similarly, we're going to do the ammonium sulfite, and once again, we have the ammonium piece. Sulfite is SO3 2 minus, ite. And now once again, we can swap the charges since the charges are not the same. 2 comes down on the ammonium, and since there's only one ammonium ion with the charge, then it's just the sulfite part. And then finally, ammonium sulfide. What does a sulfide mean? Well, that means that it is a it is an S2 minus. Ide means the atom, and so now we have the ammonium again, but now we have the sulfide part, which is the sulfur 2 minus. How do I know it's 2 minus? Because if I look on my periodic table, I go plus 1, plus 2, plus 3, and then minus 3, minus 2 where oxygen and sulfur are, and of course minus 1's where the halogens are. And so once again, we have to cross the charges since they don't add up to 0. And so we have, y'all like my rainbow pen? I like my rainbow pen. And there it is, ammonium, and it's glitter too, if you got the resolution for it. It's got glitter. It's glitter and rainbow. All right, so it's ammonium sulfide. There it is. Okay, so this is, so if this is baffling you as what's going on, you need to go back through the chapter and and back through the lectures, and I showed you how to do this. And so my point is on this is that you cannot just jump straight to the answer. Do you see what I'm saying? You can't just jump straight to the answer. And this is so important. So important. Don't jump straight to the compound. Alright? That's what I'm saying. Don't jump straight to the compound. Do the ions first. Do the ions first. Okay, do the ions first. Why do we want to do the ions first? Because of this thing right here. You might have to cross the charges. And you might have to cross charges to get to the right compound. Now I say that and I say don't jump straight to the compound and do the ions first, because it is a very common thing that students do at this point. They want to jump to the answer. Mr. Pierce, I just want the answer. I just want the answer so I can move on with my life and whatever. And I understand. I get it. But there's certain things you have to do more than one step, okay? All right, so that's an essential skill right there. So that's where we're at with naming with ionic compounds, okay? So page 66, you need to know your polyatomics to be able to do this as well, okay? All right, so now we're going to move on to the very last piece. Let me make sure I'm on the right chapter here. And we're going to do, all right, so let me write this down here. So we just did ionic compounds. All right, that's what we just did. And they are metal with a non-metal or a polyatomic. Okay? Now we have to do covalent compounds. And a covalent compound, let me write this out so I can read it just a little bit better. Covalent compounds are nonmetals with nonmetals. All right, we spent all this time going over ionic compounds, and the naming was not easy. We had things like we had to figure out charges, we got names for things, we have to cross charges if we have to. You know, if we had more than one charge, we had to use Roman numerals, and you know, there's rules on top of rules for the ionic compounds, and I get it. But most of the covalent compounds are your more interesting things. And for simple covalent compounds, we name using prefixes. Alright, we name using prefixes, and it goes like this: mono, di, tri, tetra, penta, hexa, hepta, octo, nona, and deca. And this means 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now for simple compounds, that's what you use. All right, simple covalent compounds. But remember, this is non-metals with non-metals, and the bonding is completely different for covalent compounds compared to ionic compounds. Okay, ionic compounds are otherwise known as salts, and everything else in the world is a covalent compound. Now, how do we do this? Well, we have these things right here. Let's say we have NO2. Now, that's not the nitrite ion. To be the nitrite ion, it would have a minus on there. This has no charge on it. It's a nitrogen with 2 oxygens. Okay? Now, is it an ionic compound or a covalent compound? Well, we have to look at it, and we have to look at our periodic table, and we say, well, nitrogen, I look on my periodic table, it's over there with the nonmetals, and I see that the nitrogen is attached to oxygen, and I look on my periodic table, and it's also a nonmetal. Anything up and to the right of your metalloids is a nonmetal, and I see that both of these elements are nonmetals. So this thing is covalent. So it is covalent. All right, so I know it's covalent. I checked. Nonmetal, nonmetal. Now, to name this thing, you name what you have and you put what's in front of it. So we have nitrogen. Okay, and there's only one. And by the way, if it's the first element, we don't use mono. All right. If it's the first element, we don't use mono. But let me make sure there's nobody trying to get in here. It doesn't say. All right. And so it says nitrogen. And that's all we got. We have the nitrogen there. Now we have to look over here and we see what's next. We have an oxygen. Now, as usual, when we end, we're going to change. When we have just an atom, and that is just an atom, the oxygen is just an element, we say oxygen, we say, what do we say? We say ox, let me fix that, oxide, right? So it's nitrogen oxide. Nothing's changed so far, right? We name, the first part, we named the second part, we changed the ending to IDE. Now what's going to change here, though, is what do we do about that 2? Now, when we had the ionic compounds, I said, don't do nothing with that 2, right? When I had ionic compounds. But this is covalent, and we're going to go by prefixes. So we say 2, we look over here, and we see 2 means di, and we say dioxide. So that is nitrogen dioxide. It's a covalent compound. It has 1 nitrogen, it has 2 oxygens, and we say it's nitrogen dioxide. Now, a close cousin to NO2 would be, now this is in the gas phase, by the way, is if you liquefy this, you turn this into rocket fuel, and we have N2O4. All right, so we go from nitrogen dioxide, and we go to something else. And this, by the way, is rocket fuel. And how would we name this? Well, we do the same thing. We start with the left and we go to the right. We go left to right, and we say, well, you know what? This is nitrogen, right? Nothing's changed here. But what do we have here? We have a 2. And so we have to put a, what does 2 mean? 2 means di-nitrogen. We have a 2 there on the nitrogen, so that means dinitrogen. Now we're not done yet, because what do we have over here? We have an oxygen. So we have to say oxide again, because it's the last one and it's the element by itself. And anytime we have an element by itself, we chop the end off and change it to IDE. Okay? But now what do we have? We have, let me circle this with a different color. Let's go back to my rainbow, and there it is. We have my 4. And what is 4? 4 is tetra. And so this is tetra oxide. Now, you can also say tetroxide. You can say either tetraoxide or you can say tetroxide. Which one is better? Actually, they're both the same. It depends on where you learned chemistry, and what part of the country you're from, and maybe even what part of the world you're from, whether you would say tetraoxide or tetroxide. Matter of fact, there's a lot of chemistry is like that. When we think of chemistry and science in general, we think that it's this way and only this way, and this is the way it is everywhere. No, actually, things are different depending on where you're at. Like, for instance, if I say aluminum, the metal, aluminum, what would they say over in Great Britain or the rest of the world? They would say aluminium. Aluminium. Now, if you go anywhere else other than the United States, they say aluminium. And there's actually quite a few elements that are pronounced differently depending on where you're at. And so tetraoxide or tetroxide, both legitimate. All right, they're both legitimate. All right, so let's try. Let's try, because we should always try things. How about we do, I don't know, let me get my periodic table out here so I can make up an element. How about let's do what would be the names of these guys? There's two of them here. I'm not trying to combine them. I'm just saying you have two things to name here. You have a job. You only have one job, and that's to name these two things. All right. We have N2O5 and ALN. So what would you call those things? And so the first question that you have to ask yourself is it ionic or is it covalent? You have to ask yourself that, okay? And the first compound, N2O5, well, what do we have here? We have a nonmetal with a nonmetal, so this is covalent. How about that ALN? An aluminum with a nitrogen. Well, this is ionic. So the naming's going to be totally different for these two things, aren't they? So what do we have here? Why don't everybody type down what you got? Just type in the chat box. What do you have for these two things? Do the first one and the second one at the same time in the chat box. Just type it out. Type the name. What do you think? By the way, if you should agree, I hope, that naming covalent compounds is a heck of a lot easier than naming ionic compounds. Dihydrogen pentoxide, very good, Lizzie. And whoever was that before that flashed ahead, yeah, dinitrogen pentaoxide. Yeah. And the other one is what? What's that ALN? It's what do you think? Oh, somebody left the meeting. Oh noes. Yeah, aluminum nitride. There you go. Good job, Emma. All right, so let's see. So this would be two nitrogens. That makes this dinitrogen. And this is 5 oxygens, so that makes that penta or pentoxide or pentaoxide. They're both legitimate, by the way. You can either say pentoxide, or you can say pentaoxide. Okay, either one's legitimate. Yeah, it's dinitrogen pentaoxide or dinitrogen pentoxide. And this guy up here, well, this is ionic. You name the metal. Aluminum nitride, Y-ide, because it's the element, right? That's the element. All right, what would you call this guy right here? What would you call that? Anybody know? What would you call that? Just type it in the box if you know. This requires you know what's on page 66, right? And so, anybody got an idea? Very good, JD. Very good. Aluminum nitrate. Very good. Very good. And speed's important on this. Aluminum nitrate. It's an 8. Okay, NO3. How do you know it's a nitrate? Because you memorize your polyatomics on page 66. That's how you know. How about this guy right here? How about, let's do another compound. How about, oh, I got one. How about, what do you got there? S2F6. What do you have? Is it ionic or covalent? Well, yeah, it's covalent, right? Non-metal, non-metal. Sulfur and fluorine, yeah, definitely non-metal, non-metal. So what do you got? What is this in green? What you got? This is about 80% of the point of chapter 2. About 80% of the point of chapter 2. Disulfur hexafluoride. That's what Faith says. And I would say Faith is right. It's great. I have faith. Yes. You got it right. Yeah, it is. It's disulfur fluoride. Disulfur hexafluoride. So, di, because there's two of them. Sulfur, because that's what S means. And there's 6 fluorines, so we say hexa. And it's fluoride. By the way, U comes before O in fluoride. But if you say OU, I'm not going to yell at you. Okay, I'm not going to yell at you because everybody does it. Yeah, so you have hexafluoride, disulfur hexafluoride. There you go. See, it's easy peasy. But I'm telling you, to be able to do this, you have to practice. There is no way around this. So go to Google when you are done working all the red problems in chapter 1, and you've done all the red problems in chapter 2, and you've done all the examples, okay? Go to Google. How do you do Google? Is it 2 O's? Yeah, it's 2 O's. Google naming worksheets and work them, okay? You can never get enough practice with naming. Okay, you never get it. And by the way, if you don't get your naming down, it makes the other chapters a lot harder. Okay, it does. It makes the other chapters a lot harder. So, any questions on naming? Okay, the rest of it's practice at this point. Okay, the rest of it's practice. Let me see, make sure that I have done everything. On your own, I'm not going to do this, but on your own, there's some basic organic molecules that are listed. Things like CH4 is methane, C2H6 is ethane, and so forth. Do that on your own. I don't really hit the organic stuff. There's a little bit of it, just kind of like an intro to a little bit of organic. You'll hit that next year if you're in 251. I don't know why they stick it in here, except maybe just, to give you a little bit of exposure to some organic molecules. Okay? Alrighty, so let's move on to chapter 3. Alright, let me change pens here. This is the last chapter before the first test. Alright, and this is all about reactions and calculations. Alright, and this is the stuff that is hard. Okay, and I've been telling you, the stuff we did in chapter 1 is almost like, yay, we're in chemistry. Chapter 2 is sort of like, well, this is how you kind of name things. Okay. Chapter 3, you've actually got to start taking the problems apart, figuring out what you need, putting them back together, getting them set up, and then after you do all that, it's got to end up in the calculator. And then you've got to get an answer, okay? And it's multi-step. Okay, it's multi-step. And and we'll warn you right now, if you skip any steps, you won't be able to do it if you skip any steps. But don't skip any steps. I'm not going to leave anything mysterious here. In other words, you will know everything you need to know. All right, so let's start with the reactions. All right, so in the beginning, we had reactions. And we have a reaction that looks like this. All right, and let me put some things on here. All right, this is just your first reaction. Okay, now we're doing chemistry. After all of this, we're actually going to start doing chemistry now. So we have this reaction. This is a reaction. This is a reaction of CH4, which is otherwise known as methane. Okay, this is methane. It's the common name. This is oxygen gas. How do I know it's a gas? Because G stands for gas. All right. This is, what is CO2? What is CO2? Well, let's see, that's a nonmetal with a nonmetal, right? Hey, look, this stuff does not go away with the naming. Just because we're on chapter 3, it doesn't go away. And so this is CO2. This is, we name this with prefixes. So this is carbon dioxide. Okay. And what's H2O? What's H2O? Anybody know what H2O is? You don't know what H2O is? It's all right. It's dihydrogen monoxide. Now, I want everybody to write their congressman and tell them that there's this horribly dangerous chemical that needs to be banned called dihydrogen monoxide. And I guarantee you, by the end of the night, it will be on Twitter and it will be on the news about this horrible chemical that needs to be banned called dihydrogen oxide. And if you do want to have some dihydrogen oxide, you will have to have a license and a permit. All right. Now, well, H2O is, what is it? It's water. Yes, good old water. No, you do not need a permit for dihydrogen monoxide. All right, and don't try that on your congressman, because they will truly believe that it is dangerous. Lately, they're not very smart, that's for sure. Okay, so we have this reaction here. Now, I just named the stuff that's going on. Now, for any reaction, we have a left-hand side and we have a right-hand side. Okay, so everybody, what's your left hand? What's your left hand? Okay, that's your left hand, right? Everybody knows their left hand. And what's your right hand? Okay, now look, it may seem silly, but you would not believe the number of people who do not know their left-hand side from their right-hand side. Okay, so this reaction has a left-hand side and a right-hand side. And when we say left-hand side, right-hand side, we mean left of the arrow or right of the arrow. Now, for those who've had high school chemistry, okay, I understand. You're saying, I get this, but I always assume that nobody here has had chemistry. And I also assume that even if you did have chemistry, that you were not taught correctly. So bear with me if you've seen this, okay? So we're starting from the very beginning, okay? It's the only fair thing I can think to do. So we have a left-hand side and a right-hand side of that arrow. And on the left-hand side, we call these reactants. If it's on the left-hand side, it's a reactant. If it's not on the left-hand side, it's not a reactant. It's something else, okay? So it's got to be on the left-hand side to be reactants, no matter what the equation looks like. So I've had folks say, well, it can't be reactants because it just doesn't look right. No. If it's on the left-hand side of the arrow, it's a reactant. Now, on the right-hand side of the arrow, we have what are called products. All right, so we have left-hand side, we have reactants. On the right-hand side, we have products. Now, another name for reactants is starting materials. All right, and another name for products is ending materials. All right, that's another name. So we have reactants, otherwise known as start materials, and we have products, otherwise known as ending materials. Okay, everybody with me so far? All right, now, when we have a reaction, we must observe what's called conservation of mass, which means whatever we start out with as far as atoms go, we should end up with the same atoms on the other side. Okay, so when we do a chemical reaction, we're just rearranging things. And so we need to have the same number and kind of atoms on both sides. And we call this balanced. This is a balanced equation. And when we have the same number and kind on both sides of atoms. Now, is this equation balanced up here? We have CH4 plus 2 oxygens plus 2 CO2s gives me 2 H2Os. Now, before we answer that question whether this is balanced or not, we have to realize, first off, what do these numbers mean? This 4 right here means 4 hydrogens. This 2 means, let me write this out just a little bit better. This 2 means 2 oxygens. Okay, everybody with me so far? Now this 2 in the front, on the other hand, let me change colors here to blue. This 2 means 2 of everything. Alright, same thing here. This 2 right here means 2 of everything. Alright, the 2 on the hydrogen just means 2 hydrogens. Alright, y'all with me? Alright, and so how many carbons do we have? We have on the left hand side, we have 1 carbon, and that's it. And on the right hand side, we have 1 carbon. On the left hand side, I have 4 hydrogens. I have 4. 4 times 1 is 4, so we have 4 hydrogens. And on the right hand side, we have 4 hydrogens because we have 2 hydrogens here, but it's 2 of everything, which equals 4 hydrogens. Y'all see that? So we have 4 hydrogens on the right hand side. Now let's take a look at the oxygens. We have 2 for the molecule, and there's 2 of the oxygen molecules, oxygen gas, so we have 4 oxygens on the left hand side. Now how many oxygens do we have on the right hand side? And this is where you have to be very careful with attention to detail. We have 2 oxygens here, but what do we have over here? We have 2 oxygens over here as well. Look, 2 of everything. Okay, so if there's 1 oxygen in an H2O, but there's 2 of everything, that means you have 2 altogether. You have altogether, you have 4 hydrogens and 2 oxygens. And oh, by the way, you also have, let me circle these in green, you have 2 places where you have oxygens. You have to be very careful that you look through and you look at everything when you're trying to figure out whether you have the same number on both sides. So sure enough, we have 4 oxygens on the right hand side. We have 4 oxygens on the left hand side. Y'all see that now? Very easy to focus in on just one or the other and forget to do both. Very easy to focus in on one. So this equation is balanced. It is balanced as written. Okay, now our skill is going to be to balance equations. That's what we're going to start out with. So here's our skill. Balance equations. Okay, balance your equations. That's our skill that we're going to start out with for chapter 3. All right, now let me show you how to balance a combustion reaction. Okay, this is called a combustion reaction. Combustion. And I'm just going to hit you with the type of, instead of listing the type of reactions, I'll just name them as we go along. This is combustion because we're burning with oxygen. O2, and we're making CO2 and water. All right, we're burning with oxygen and making CO2 and water. You have to have both those conditions for a reaction to be combustion. You do have to be burning, combustion, burning with oxygen, and your products must be carbon dioxide and water to be a combustion reaction. Okay, so we have this combustion reaction up here, and step one. These are our steps. Remember what I said? If you follow steps, you can't go wrong. Step one. Check and see if balanced. Because a lot of times you have reactions and they can go ahead and be balanced. They can be balanced. Alright, so I check here and I look up here and I go, one carbon, okay, carbon's good. 4 hydrogens, oh wait, 2 hydrogens on the right hand side. It's not balanced. Okay, number 2. Generally you start with biggest molecule and balance left to right. Left to right. Okay? Now, I'm going to balance this. Now, the biggest molecule up here, well, you could say it's CH4 or CO2. And by the way, of balance equations, it's about half pattern recognition and half following procedure. So we're going to start with the CH4. We're just going to go left to right. And so I look at the carbon. I see one carbon. I'm looking right there. See that one? Right there with that blue arrow. And I say, well, you know what? There's one carbon. And I look over here. And I see one carbon. I say, all right, I'm good. Good with the carbon. And I move over to the next one and I say, you know what? I see, how many hydrogens do you see on the left-hand side? What do you see? You see 4. You see 4 hydrogens, right? And I see 4 hydrogens right there. And I look over here and I see 2. So what do I need to do? Well, I need to put a number in front of one of those 2 guys. I have to put a number in front of them to make the number of hydrogens equal. Okay, now understand, I'm focusing on one element at a time. So I'm looking just at the hydrogens. And so I see there's 2 hydrogens over here. I see there's 4 over here. I'm going to put a 2 there. Now I have 4 hydrogens on both sides. Now the reason why I said we're focusing on just one atom at a time, if you look, what happened to the oxygen when you put that 2 in front of it? What happened to the oxygen? You went from 1 to 2. Okay, so you did change the number of oxygens. That's okay. We're focusing on one thing at a time. Okay, so now we've balanced the hydrogens. So the carbons are balanced, the hydrogens are balanced, which means this whole molecule is now balanced. All right, now, step 3. Skip diatomics. Skip diatomics and atomics for last. All right, and the reason why I say that, if we're working left to right, what would be next? It would be the O2. Well, O2 is a diatomic. So di means 2 atoms. Okay, O2 is a diatomic. So we're going to skip the diatomics for the time being. And so I skip over the O2 and I go to CO2. And I say, you know what? What do we have here? I've already balanced the carbon, so I know the carbon's okay. Already balanced the carbon. And I haven't balanced the oxygen in CO2. I know I've balanced the hydrogens over here, but I have not balanced the oxygen. So what's left to do? This is already balanced. Okay, as far as the carbons go. This is already balanced for the hydrogens. So we have to balance the oxygens. As a matter of fact, so what does that mean? It means we are actually at step 3 now. So we look over here and we say, how many oxygens do we have on the left-hand side? We have 2. How many oxygens do I have on the right-hand side? And remember, you have to count them all. So we have in the CO2, we have 2 oxygens, but in the H2O, we have another 2 oxygens. See the 2? You see that? 2 times 1, there's an implied 1 there. There's 2 oxygens. So how many oxygens total do we have? We have 4 oxygens on the right-hand side. Okay, so now we need to look. We're going to look. And we want to know, what do we need to put in front of the O2 to make 4? We need to put a 2. Because 2 times 2 is what? 4. You have 4 oxygens, now you have 4 oxygens on both sides. And so we go back through and check this, and we see that we have 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, and I'm saying, when I say 4 hydrogens, I mean 4 hydrogens left, 4 hydrogens right, 4 oxygens left, 4 oxygens right. And so this is now balanced. It is balanced, okay? So we went through and balanced this. All right, let me show you another one here. Let me show you. Let's just show you how to balance these things. So after you see a few, you might start seeing there's some patterns going on here. All right, so let's take a look at another one. How about C4? Let's do another combustion reaction. H10 plus O2 goes to carbon dioxide plus water. And I want to balance this. Now, this is where if we were in class, I would say, everybody give yourself a shot, in balancing it. But I'm going to show you how to do this because I can't see your expressions or anything. So I'm going to say, all right, how do we do this? Well, let's do it the same way. We take a look at carbon. How many carbons do we have? We got 4. And so I look over here and I see there's 1 carbon. So what do I need to put here? I put a 4 for the carbons. Okay, so I'm done with the carbons over here. I take a look at the hydrogens. Remember, we're working left to right. Remember? Left to right. And I see that we have 10 hydrogens. And I look across here, and I look across, and we change colors a little bit, and I look over here, and what do I see? I see there's 2 hydrogens, right? There's 10 over here on the left, there's 2 on the right. So what do I need to do? I need to put a 5 there, because 5 times 2 makes 10. Okay, so the hydrogens are balanced. And we're done with the C4H10, which, by the way, is, in case you're interested, it is butane. Same stuff in butane lighters. Okay. And so remember, we skip over O2 because O2 is a diatomic. So we're going to skip over that. And we go to carbon dioxide, and we see the only thing left to balance on the right-hand side. We've already done the carbons. We've already done the hydrogens. The only thing left to balance is the oxygens. And so I look and I say there's 4 times 2 gives me 8, plus 5 times 1 gives me 5, and that gives me 13 oxygens. Okay, so how to get 13 out of O2? How do you get 13 out of O2? Well, you could use a fraction. You could say 13 halves times 2. Well, let's not do fractions. What we can do, though, is we have to recognize that 13 is an odd number. This is odd. And you're never going to get an odd number out of an even number. Everybody agree? Because, if you go, If you go 2 times 1, you get 2. If you go 2 times 2, you get 2. If you get, 4. If you go 2 times 3, you get 6, and 2 times 4 is 8. So no matter what you do, if you multiply times 2, which is O2, it's an even number, you always get an even number. All right? You can't get an odd number out of it, not with a whole number. So what can we do? What we can do is we can multiply everything times 2 everything except the O2, because that's not what we balanced yet. Times 2 everything. And let me do it first. So I say 2 times 1 is 2. Skip over the oxygen. 2 times 4 is 8. And 2 times 5, let me make sure nope, hold on. That's an 8, yep. 8 times 2, that's 10, 16, 20, yep. And 10, 2 times 5 is 10, okay? So I multiplied everything through by 2, except for the oxygen. You may say to yourself, but wait, Mr. Pierce, but wait. How can it possibly be balanced anymore? I went through all that trouble of making sure, I had 4 carbons, and I put down there were 4, and I said, there were 10 hydrogens, and I put down, 5 to get 10 right? I went through all that trouble, but you know what? It's still balanced. Because what's 2 times 4 on carbon? That's 8. Now you have 8 carbons. You still have the same number of carbons on both sides. What's 2 times 10 for the hydrogens? That's 20. What's 10 times 2 over here on the water? 20. So it's still balanced. Except now, if you count it up, what do you have? Now you have 16 oxygens and 10 oxygens, which gives me 26 oxygens. Oh, wait a minute. Now we can say, what times 2 gives you 26? It's 13. Now the equation is balanced. So you have 2 butanes, 13 oxygen molecules, 8 carbon dioxides, and 10 waters. Y'all see that? So this happens when you have even or diatomics. It happens about 50% of the time. About 50% of the time. All right, it does. It happens. And it makes sense. Half the time it's even, half the time it's odd, right? And so it does. It happens. Okay? So when you're doing combustion reactions, or any time when you have diatomics like oxygen, which is O2 or Cl2 or Br2 or I2 or whatever, you may have to do that. You may have to go through and multiply everybody through by 2. All right. Now, let's do another one. Now, let's say that you had the following reaction. Let's say we had this going on. All right, so this is the reaction of what? This is some sort of iron oxide, right? How do we name this? Fe2O3. We would say this is what? This is iron. What kind of oxide? Iron Roman numeral 3 oxide. This is what? Carbon monoxide. What is this? This is carbon dioxide. And what is this? This is just iron, right? Okay, why am I doing that? Because you need, even when you're doing balance and equations, you need to be naming these things. Why do you need to name them? Because you know what? Next week, you're going to have to name some things. And if you don't have practice, it's not going to end well for you. Okay, so make sure that you're always naming things. Always naming. It's not part of the problem, but it's good practice. Good practice. Okay. All right. So What do y'all think? Y'all want to? I'm sure some of you are equation balancing pros, and some of you need a little bit more help. And so why don't y'all go ahead and try to balance this? And when you're done, type in the box and say done, and then you can go like 1 2 2 1, whatever's in front of the, like let's say if it was balanced and you say it's 1 iron 3 oxide with 2 carbon monoxides gives me 2 carbon dioxides plus an iron. Okay, so that's the format I want you to use. So let's take a few minutes, everyone, and let's go ahead and let's see if we can balance this equation. Okay, and this is how I want you, when you're done, I want you to type it in the box just like that, in the chat box. So let's take a few minutes. Everybody do it. It's important that you try. Even if you get it wrong, it's okay. It's okay if you get it wrong, because we can fix it. It's better to fix it now than to try to fix it next week. Okay, see what I'm saying? So everybody just do it. Go ahead and do this equation. Let's see what we get. I'll give you a few minutes. Matter of fact, while y'all are doing that, I'm going to run and get a glass of water, and I'll be right back. Okay, so keep working on it. Keep working on it. I'll be right back. One, 3, 3, 2. Kiana Moore. 1, 3, 3, 2. That's interesting. 1, 3, 3, 2. We got at least one answer. By the way, I just came back, so if you posted your answer, then I didn't see it. But I did see Kiana Moore, and she says 1, 3, 3, 2, and Samantha says 1, 3, 3, 2. Interesting. Interesting answers. Yes, they are. I always have to say interest because it makes people go, oh my God. Yeah, oh my God. 1, 3, 3, 2. Anybody else get 1, 3, 3, 2? That's an interesting answer. Interesting. Interesting. Truly interesting. Alright, so let me see what I get. Let me erase this over here. So, alright, so this is how I'm looking at this. I'm looking at this carbon monoxide goes to carbon dioxide. And so this carbon monoxide, when it goes from here to there, it gains an oxygen. Alright? And there's 3 oxygens over here, so therefore this must be a 3 here to take care of those 3 oxygens become 3 O2s. Okay? And then that becomes 3 there to get that. Okay, so now we have, let's see, we've got 3 plus 3 makes 6 oxygens. 3 times 2 makes 6 oxygens on the right hand side. And now I look at the 2 and I go 2 over here. And let's see, did I finish that right? Let's see, 1, 3, 3, 2. What do y'all think? Is that right or not? Yes or no? What do you think? Let's see, we got two irons, 3 oxygens, 3 oxygens makes 6, 6. Let's see. And 2 iron. Yeah, looks like it's right, doesn't it? So our answer is 1, 3, 3, 1, 3, 3, 2. Easy peasy, huh? Easy peasy. It truly is. Okay. But how do you do these? How do you get good at this? And I'll tell you how you get good. How to get good. How do you get good? good at this. What do y'all think? Anybody have an opinion on how to get good at this sort of thing?
Practice.
Yeah, there you go. Practice, practice, practice. That's what you do. Practice. Practice with the answers. Make sure when you're practicing you have the answers, right? So you can compare. Like I said, there are lots of, if you go to Google balancing equations worksheets, and there will be worksheets that come up with answers. There's equations you can answer in the text, and you can get all the practice you want. It is an essential skill. Okay, balancing equations is an essential skill. Okay. All right. So what I'm going to do now is we're going to take a break. Okay, because we got to keep going. All right. So we're going to take a break. I'm going to stop recording.